In this presentation, we're going to have a quick look at Numpy arrays. They're the sort of fundamental component of the Numpy environment. So essentially, everything in Numpy is essentially just based about building arrays and performing calculations on them. Really, that's in a nutshell. It's a bit blunt, but that's good enough description for 5 seconds. All elements of an array. This is sort of an important thing of an array, as opposed to lists and stuff like that that you might find elsewhere, is that they all must be of the same type. And an array can have any number of dimensions. We can have single dimensional arrays, which we're going to start off with. We'll have two-dimensional arrays, which are similar to matrices in mathematics. You could have multi-dimensional arrays. So anyway, start us off. Let's import NumPy, and we're going to call it MP, just to give it a short name. And what we're going to do here is, first off, you set up these things called a tuple and a list. Now these are sort of fundamental data types from Python, not necessarily part of NumPy or pandas or something like that. So we have my tuple and my list. And essentially, tuple is the round bracket and the list is the square brackets. Okay, and there's just a series of numbers. Incidentally, what I've done there is in the tuple I've just put in integer values. Okay, so there's no decimal points there. Whereas in the list, I have a couple of decimal points knocking around. That is to say that it is a float, as we call them or real numbers, how we might say it in mathematics, but in computer science you might say a float. So what are the types? Now, just actually, if you're not used to IPython notebooks, this is what they call a print command. Where is it? And sorry, I just skipped past it really quickly. So this is a print command, okay, and really it's slightly unnecessary. It's just actually to print multiple outputs from the same cell. This is a cell here. This green, what this green line is around, is just an so this is one cell. This is the next cell down here. Go back to this cell. It's really just to sort of have multiple outputs from the same cell, just for the sake of comparison. So we have the type of my tuple is a tuple, and likewise the type of my list is a list. Okay, so let's set up a NumPy array. So what the command is really array, okay? And if you're sort of working the way I'm working, import NumPy as NP. This is how we might import the module. So if you're using something from the NumPy package working this way, there's other ways to do this, which I'm not going to explain this time around. If you're using a command from the NumPy array, you just have to sort of specify NumPy, or for the NumPy package, you just have to specify NumPy, but you can shorten the name just to save typing, so you can sort of NP, and so specify the NumPy package, then the command array, and so on. Now, the bracket here is the sort of the input for this function array, okay, and you can put in a input. So I'm going to put in this little list here, okay. So it's a bit confusing when you have a round bracket and a square bracket. The round bracket is to sort of say what's between the round brackets is the input for this function, and the square bracket is just define whatever's in that as a list, okay. So A is the first arrays we're going to use. We also have B and C, which is my tuple and my list, okay. So there's just three ways of coming up with building a very simple array there. The B and C are very similar actually. They just to actually make one sort of point that if you provide a tuple or a list, you're going to get an array no matter what. So ultimately, what A, B, and C, we all end up with the same thing here. We end up with a NumPy ND array. That means n dimensions. So you could have a single dimension, two dimension, or multi-dimensional arrays. Okay, so that's the type of A. That's quite important. It's also, let's have a look at this now. D type. So I have set up B here. Okay, and B is my tuple, which is the integer values. Okay, from earlier on, turned into an array. Okay. And let's look at this. D type is actually sort of like a way of checking what data type is in B. And if you look at this, the output from here says int 32, which is to say it's an integer. Okay, the D type is the data type is an integer. Okay. Likewise, C.D type, the data type of the array C, that's a float, which is, let's say, it is real numbers, okay, or decimal numbers with decimal points in them, okay. Now there's a couple of other commands here that are quite useful. You can, and again, I'm using the print command here, so I can sort of group all four of these examples into one cell. The length of B just tells us how many values are in B. It's quite useful. That sort of is sort of general to Python. It's not specific to NumPy. B.shape gives the shape of B, the array B. So we have a tuple here that essentially says 6, but 6 by it's just a 6-element array basically. So it's a 6. It's no more dimensions to it. So if we had, for example, a two-dimensional array, you might have 3 by 2 or something like that, or 3 by 1 or something like that. Size, how many elements are in B, and also ndim is the number of dimensions. Now you might often later on be dealing with multi-dimensional arrays, which actually have quite a lot of dimensions in them. It sort of makes sense if you're doing some high-end engineering calculations or something like that, or physics. So it's just handy to know. So that's the number of dimensions, and it's a single-dimensional array here. Okay, you can convert between types. So remember we said earlier on that B. Let's just take this out for a second. B was a integer array earlier on, but you can actually turn it into a float just by specifying float also. So that turns it into a float. You notice these decimal points here. Okay. Also, you can turn a float array into an integer array. Now watch this. Be very careful with this. So here we have C again. I've printed it out here. 1.1, 1.5, 2, and 4.1. Okay. And sorry, I'm just going to run that again. And I have npc int as 1, 1, 2, 4. So it just actually rounds it down. So when you turn that into an integer, 1.5, it just turns it into the integer 1. It just rounds it down to the nearest integer. Something I was messing around with before I got started is that there's actually other data types. You can actually have complex numbers if you're doing anything with mathematics, and you can actually write these as complex numbers as well, convert it into a complex number array. Okay. You can also have string values, arrays of strings. Sometimes that's useful. But essentially, there's a couple of things like categorical types later on that are worth mentioning. But it just actually sort of say, really the point of this really is just to sort of say it's not limited to numbers. You can have other things as well. There's character arrays, character types, and categorical types, which is an interesting topic, but something I'm going to sort of wait for another time. Again, we have the type here is D is a NumPy array. This is sort of essentially is a sort of the D type of this essentially. That's not particularly clear, but it essentially just says it's a string. This is the last one I'm going to do. E, this array here, NP array is true, true, false, true. Now you notice that's in green. This is a reserved word, and it's for the Boolean state, true or false. So Boolean state are the two main logical states. There's actually a couple of other ones like missing values and so on, but we usually look at the dichotomy of true or false. Although you could have missing values as well, which is also actually part of it. So true or false. And that is a NumPy array as well. So it's actually just passed as a list of true or false values. And it's actually what they call a Boolean type. I'm just going to write that down here. It is... Actually, I'll write it up here. Boolean types. Boolean data types. And that is it. Let's see, I will go on to two-dimensional arrays now shortly.